Very good morning to all of you. Myself, Mr. Mabudur Rahman, Assistant Professor in the Department of Food Engineering. Today, I will cover a numerical problem based on production rate in space requirement. First of all, you are seeing here that the production rate of the department, that is a major determinant of the amount of space required. The production rate of processing station, that is the number of units produced per time unit. The production rate, it can be determined from a marketing forecast of the finished product. You are seeing here the diagram. A, it is the arrival rate of raw material, D is the demand rate of product, and P is the production rate of processing station, and S is equal to scrap probability of an inspection station, and R is equal to rework probability of an inspection station, right? So A, P, D and S, I think each and everyone understood. A is the arrival rate, D is the demand rate of product, and P is the product rate of processing station, and S, that is the scrap probability of an inspection station, and R, rework probability of inspection station. Now see here the example. Consider the operation chart shown in the figure. The percentage of rejected part is how much for 1, 2, 3, that is 5%, 4% and 6% respectively. So the annual operating time is 2500 hours and the annual demand forecasting of the product is 4,90,000 units, and due to possible forecasting errors 10,000 additional units per year are required. So we want to calculate here what? Find the production rate at each station. Station 1, 2, 3, 4, 5 and 6, right? So before calculating the production rate of unit 1, 2, 3, 4, 5 and 6, we calculate the value of D, because D will be depends on calculation. So first of all, from D is equal to 4,90,000 plus 10,000 upon 2500. So when we calculate, we obtain 200 units per hour. It means it is our good units, right? After that we calculate P5. P5, that will be equal to P6, right? That is the last station. Okay, not last station, but that will be the last station 5 and 6. So when we calculate the value of production rate here, it will be depends on D, and D is our 200 upon 1 minus S3. So when we put the value of S3, so we obtain 0.94. so that will be divided 200, that will be divided through 0.94. so we obtain 212.76 units per hour. That is the production rate of P5 and P6. It means the unit of 5 and unit of 6, right? And after that, okay, after that we calculate what? P3 and P4. Okay, so it will be depends on P5, right? So we obtain the value of P5, 212.76 units per hour. It will be divided by 0.96. So we obtained how much? 221.63 units per hour. After that we calculate first and second station P1 and P2. So that will be depends on P5. So it will be multiplied with 212.276 into 2 upon 1 minus S1. So when we divide it 0.95, the value of 212.76 into 2, when we divide by 0.95, we obtained how much value? 447.92 units per hour. So in this way we calculate the production rate of all stations. Next example is, consider a product that require a single operation. After the operation, it is performed each unit that is inspected. A unit passes inspection with probability 0.92 that is scrapped with probability 0.05 or has to be reworked with probability 0.03. If the demand for this product is 82,000 units per hour and the annual operating time is how much? 2500 hours. So determine the production rate at the processing station. So before calculate the processing station rate, we calculate the value of D. D is depends on our demand units per year, as well as it also depends on annual operating time. So when we divide it 82,000 divided by 2500, so we obtain the good units 32.8 units per hour. After that we calculate P. P is equal to D upon 1 minus S minus R. So D, that is 32.80, we put it and we put the value of 1 minus S minus R, that is 0.92. After when divide this value, we obtain 35.65 units per hour, right? And last we calculate the production rate at the processing station. A is equal to P into 1 minus R. So when we multiplied 35.65 into 1 minus R, it means 1 minus R, we put the value 0.97 and multiplied with 35.65, we obtained 34.58 units per hour. In this way we calculate the value. Okay, thank you for listening. Once again, thank you.